I spent over $5,000 on this incredibly rare Emmert 10A Universal Bench Vise, only to find out that it was in way worse shape than I expected, with multiple broken parts that required some brazing, a bunch of tuning and fixing, some machining to make brand new parts, and just overall a tremendous amount of work. So let's get right into the restoration of this Emmert 10A, one of the rarest and most sought after bench vices. And we're going to start by just taking it apart. And this is a huge vise. It weighs 250 pounds. And if you're familiar with my other Emmert number 4 Universal Bench Vise, which has been seen by millions of people on the internet, these are very, very rare and very cool vices. Now, this has a totally different mechanism on a bunch of different features, but generally it is similar with that round turret and the 3 jaws that allow you to grab all sorts of different work, and you can also flip up the whole assembly to go vertical or at an angle. Now, this is a really, really crusty vise. I was very surprised in how bad of shape it was in when I got it. And the seller that I bought it from on eBay, he was a really nice guy. He told me he got it out of a barn. He said it thought, to be complete. So I bought it, and I'm not going to go ahead and try to get any money back considering how bad the condition was, because you know what? I bought it used and it's 100 years old, so it is what it is. But you'll see later on in the video how many things are broken. Now I'm going to be using the WD-40 Specialist Penetrant Spray to try to get this bottom swivel lock open. And this video is actually sponsored by WD-40 brand, and they really helped me out with this project. There was a bunch of different areas that needed to be soaked in their rust removing soak, and the WD-40 Specialist Penetrant Spray is a really great product for getting anything loose or stuck freed up and moving again. So now to try to get the screw out of the main column here, the little set screw was of course stripped, so I used some left hand drill bits and an extractor set to try to pull that out. Now this is a pretty delicate little part, so I wanted to be careful not to damage any of the screw itself, but once I was able to get that screw out with the extractor, I slid the collar off and I was able to remove that screw and handle. Now, what you may have noticed is that there isn't what's called a meatball on this, and it's all welded up, but we're going to fix that later on in the video. So the first thing I wanted to do was get everything into some WD-40 Specialist Rust Remover Soak so I could try to get these things cleaned up as best as I could. And what I noticed when I was taking this apart was that this main nut seemed to have a couple small cracks in it. Now, I put it in the soak and I let it sit overnight just so that I could kind of clean it up as best I could and then really get a look at it so I could try to do the repair. Now, this was the first part that I took out of the soak because I knew it was going to need some welding right away based on those cracks. I'm using some WD-40 Specialist Easy Pods in this little bench top parts washing thing, and basically just threw the pods in there and then filled it with water and allowed those to dissolve and made a pretty well concentrated solution of degreaser so that I could clean this part. Now, somebody went through and just greased and oiled the heck out of this thing because it was really just disgusting. And I thought if I could get some of the degreaser on there and use one of these, kind of through cleaner brushes, it would help get everything nice and clean. Then I could see what was going on. And this is when I discovered kind of the first of many problems on this vise, is that this thing is totally broken. Now, this is a very delicate cast part from over 100 years ago, so I'm not that surprised that it broke. But this would also be a very difficult part to remake, so I was really hoping that I could fix it. So in this video, I'm going to actually be doing some silicon bronze brazing versus the normal nickel welding that you maybe have seen me done in other restoration videos. I was talking to some people and watching some of Keith Rucker's videos from the Vintage Machinery channel, and I thought this would be a good candidate for some silicon bronze brazing, and in the end, I do think it worked out pretty well. Now, it's important to V and groove out the weld that you're going to do when you're silicon bronze brazing, so I'm going ahead and just grinding that out with actually a cutoff wheel that's made for grinding. It's called a duo disc. It's from Fair Abrasives. I've actually done a whole video about these, but it's a great cutting and grinding disc, and you can get into hard to reach places with it. So once I had everything V'd out, I used a little brass hammer to try to get things aligned. And originally I was going to use some hose clamps, which you can kind of see in the distance. I was going to try to get a good hose clamp on there, but then I realized I was going to have to get this part so hot that I would just be burning off all the zinc coating on those hose clamps. I didn't really feel like breathing that in, so I just gave up on that and I just used a regular clamp and just basically tried to get everything compressed well enough so that I could get it hot and then get some silicon bronze braze in there. Now you may notice I have this part up on a big piece of plate because I am going to be getting it very hot with the rosebud. I'm using a Harris rosebud to try to get this thing red hot, and then go ahead and dip some of that flux coated brazing rod in there. Now I've done some silicon bronze brazing before, but for some reason I really had trouble with this part. And I think part of it was just because there was so much impurities inside the cast iron, because these Emmerts are known to be very brittle and to fail quite often. So I was able to get a couple of good brazes on there and make a couple basically gussets to help support this thing. And once you see the way that the vise is assembled, it'll make sense why this cracked. Basically, when you tighten the vise, if you over tighten it at all, you're putting a tremendous amount of stress on this very thin cast iron part. So it's very likely that it would break under a heavy load. These are not heavy use vices. They are very cool. They're awesome to have. I love my small one of these that I use it all the time. This is not like a chipping vise or a railroad vise or something that you can really wail on, because you will break it. Now, the reason I stopped the initial brazing sequence was because I ran out of oxygen. So now what you're seeing is a couple of days later, once I got more oxygen, me actually completing the process after the part was in sand for basically 24 hours. It's incredible how much sand is able to slow down the cooling process. So basically, by putting cast iron repaired parts in sand, you're allowing them to cool very slowly, which can reduce cracking and basically eliminate it if you do it correctly. So now there's a couple of thin spots that I have to braze, and again, using the rosebud, I think I may have been getting the part just a little too hot. I also think that the rod that I had was too small. So now I'm just gently keeping it hot while I kind of let it cool down a little bit. Then I throw it back in the bucket of sand, and then I pull it out a couple days later when it's nice and cool. And then I can go ahead and continue to work on it. Now the braze is pretty ugly, so we're going to leave that to the side, and then we're going to head back over to the WD-40 Specialist Rust Removing Soak and pull out the rest of the pieces. Now, a kind of happy accident that occurred with the soak is that it actually helped strip the paint on this base, which is awesome because I was planning on getting that off anyway. The only problem is there was a lot of oil on these parts, and I did not clean them before I put them in the soak. So something to keep in mind, if you want a really, really good rust removal process, you just want to make sure the part is at least clean, because it's very difficult for the rust removing soak to penetrate beyond grease and things like that to remove rust underneath grease. So you can see, just pulling the parts out, they are incredibly clean. This is after sitting for 24 hours in the rust removing soak, and now everything's up on the table and looks really good. Now you can see the handle again and the screw. As I mentioned earlier, there is no meatball on this, so basically the screw and handle are welded together. It's a really ugly and terrible system that somebody must have done after they broke it, which should have told me that this thing has definitely been abused if somebody could break that handle and have to weld it back on. But too late now, because I'm already working on it. Now I did get a little bit of flash rusting because I let this sit for a couple of days after I soaked it. So I just went outside and really quickly went over everything with the wire wheel to make sure I got any grease or any oil, anything I wanted to get off of the thing. Now, one of the things I learned recently was you really don't want to bring a bunch of small metal wires home, especially when you have a 2-year-old walking around the house. So you can see I was wearing a leather apron, which is going to help me reduce getting any metal shavings and bringing them home with me. Now I'm over on the downdraft table using a 3-jaw chuck to hold that nut while I grind it and get some of that flux and some of that silicon bronze braze all cleaned up. Now this is actually a great little work holding trick. If you ever need to work on a part that's got a weird shape, go ahead and look for a used 3-jaw chuck on eBay or on Facebook Marketplace, and you can actually grab a lot of cool parts in it in weird ways because you've got those 3 jaws grabbing it. After using a file to clean up that edge, I brought it over to a unitizing wheel and I just was able to polish it really nicely. Now you can see all the parts nice and clean over on the welding table, where I can really kind of take inventory of what I have and how I can go ahead and start putting this vise back together. Now, one of the really critical parts on this is this little spring-loaded pin, and since this is peened on, I wasn't able to take it off to clean it up, so I just wedged a little piece of wood in there and I used a file to clean it up and then hit it with the wire wheel. Now it's functioning really well. Now this needs to function really well in order to get the vise up into the vertical or the 45-degree position. You can sort of understand the action when I put this pin back in, which only goes in one way. And once that's in there, you can see the way that the whole body of the vise moves up and down with those 4 positions. And this is in contrary and different from the Emmert 4A, which is the other vise that I have, where you can basically put it in any position you'd like. But considering that this vise weighs 250 pounds, I'm pretty sure that that movable section weighs about 150 of those 250 pounds. So having it held in by just a kind of tightening of a screw would be very difficult. And I think the pin system is actually better because it does lock things in, makes it a little easier to adjust. Now, one of the other issues I had with this vise was there was a lot of binding in the rotation of the three jaws. Now, I felt the best way to work on that would be to mark everything up with Dichem, which is a layout fluid, and then basically try to run the parts through their paces. So basically get a full rotation and try to get everything moving. And then what would happen is the Dichem would rub against itself, and then it would start to actually wear away in the high spots. This actually worked pretty well, and then I used this little kind of flap drum from Fabricating Abrasives to clean it up but not remove too much material. Now, this is a pretty frustrating process, and it was very arduous. I had to keep going back and forth and check everything. You know, getting a good fit up is really important, and then you have so many other factors that you have to contend with. Now, I'm using that same little wire drum to clean up the outside of the rotation head as well, and just sort of get everything fitted. And eventually, after a bunch of trial and error, I'm able to get this thing working really, really nice and clean and rotating great. I just kind of kept going back and forth and just removing little bits of material and adding more Dichem as I went to just sort of make sure that I wasn't taking away too much, and eventually, like I said, got everything rotating really smoothly. Now, once I put the whole thing together, there's going to be a lot more weight on it, so I have to take that into consideration when I'm doing this work and make sure that I don't wind up getting somebody bound up, you know, or having anything get stuck. And one of the other items that I noticed on here was that the actual casting was a little bit wild on the inside, so it was rubbing on the round nut. And now you can see the round nut that I brazed back together being actually put back in place, and the rotation on all this is really good. Now, this was probably one of the most important things to do on this vise, and you can see how beautifully and smoothly that three jaw spins now. And while there is a little bit of slop, when you tighten down that screw, it actually locks everything in place, so you don't have to be too crazy with that being a little bit loose. Now, the next thing I wanted to do was actually work on the meatball end of the screw. Now, I kind of modeled this after the other meatball screw handle that was on the vise. I wanted to get similar proportions and a similar shape. So I just drew this out on a piece of paper, and I basically just drew one half of it, and then I'm going to fold the piece of paper in half and use it to mirror it perfectly so I don't have to try to get a symmetrical shape on my own by eye. So once I have it done, I sort of just cut it out, and then I have this little visual representation of basically what I'm looking for in the meatball handle. And I'm going to also be obviously adding a handle itself that can slide back and forth, typical to any vise. Now, I bought this piece of steel on eBay for about $65. It's 2.5 inches in diameter, and I think it's about 7 inches long. Nope, 6 1/4. Look at that. It says it right on the piece. Now, I'm going to be turning the meatball on this by hand, just by turning the levers over on my engine lathe. Now, you can see I'm using a round carbide insert tool. I just got this on Amazon. I really don't even know the brand of it. It's nothing special, but what it's going to allow me to do is get a really good and really nice looking kind of rounded feature without having any sharp edges that I have to contend with later and grind through. Now, doing this by eye was a little tricky, but I actually am pretty happy with how it came out. After I was done, though, I did take a Polyfan curve from Fabricating Abrasives, a really good curved nose flap disc, and I just ground everything nice and smooth and made it look super nice, so that would be nice and clean. You can see it's still attached to the 2.5 inch slug, so I'm going to have to go ahead and cut that off on the big bandsaw. But overall, I think this was a good use of this material, and while I didn't want to have to buy this material, I think it was the right thing. You can see how nicely it fits in the dynamic triple jaw. Now we just have to figure out a way to attach it to the screw that came with the vise. So first thing first, I went over to the bandsaw to start cutting those handles off. And then I went back over to the grinding table, the downdraft table, and started actually grinding it to try to make it a little more round. But then I realized that it was a waste of time. So I just went back over to the lathe and I grabbed that round carbide insert tool and just started taking some passes on it. Now, I wasn't sure how this was attached. I had a feeling it was welded, but I figured, you know what, I'm just going to keep turning it until it's round, and then I'll eventually get it down into the size of a socket, and then I'll be able to put it into the meatball end that I just, spent all this time making. Now, what I did notice is as I was cutting, eventually I was starting to make some progress, getting closer and closer, and then all of a sudden the end of this thing just popped right off. So I was talking to some friends at an event recently, and they said that in some cases the actual meatball ends were cast on after the shaft was made. So I don't know if that was the case or if somebody broke it and then just jam something else on there. But like I said earlier, you'd really have to abuse this thing to break some of these parts, which lets me know that this thing had a pretty rough life. Now that I had that socket on the screw all sorted out, I needed to then drill a hole in the actual bottom of the meatball that I had just turned. Now I put my brass soft jaws on there, and then I just used my tool post to sort of act as a bump guide to get this thing turning kind of true. And then I just drilled a little hole with a spotting drill, and then it continued to work up through the different drills until I got to about maybe 1 inch, I think it was. Could be a little bit smaller, but I know that I had a 1 inch drill bit sitting around, so I think that's what I wound up using. Anyway, the idea here is that I want to have a nice socket in the end of the ball so that I can go ahead and put this on the shaft that I just turned down, and everything's going to fit nicely. And when I'm done, I'm going to cross pin it, and then I'm also going to braze it. Now you can see I made a little boo-boo there. I tried to actually turn it without that support in the center, and immediately once it got some load, it popped right out of the jaws, but that's fine. We're going to go ahead and just kind of grind down the shaft, make sure that everything is the correct size and shape. You can see the way the meatball fits beautifully on there. Now going back over to the downdraft table, I just grabbed a burr and just did a quick chamfer and bevel on the inside of the actual meatball so that there's to be somewhere for the silicon bronze to go. And you can see I've got that sitting on there. It's already looking good. I've got this set up on some V-blocks on my Sigmund welding table. And then I do this little machinist trick that I shared on my social media, which is if you have a shaft that won't really fit inside of a space, you can hit it with a center punch, and what it's going to do is it's going to raise up a couple of burrs. And by raising up those burrs, it's going to allow you to have a little bit better of an interference fit. Now you can see I'm taking that silicon bronze brazing rod and I'm getting it inside that V-groove that I just ground in the meatball, getting everything nice and red hot. And then once I'm all done, I put it in some sand and let it cool down very slowly overnight so it doesn't crack. Now you can definitely silicon bronze dissimilar metals together. That's one of the key features of it. So it worked really well to join, that mild steel to the cast iron or whatever that other cast steel was for the screw. Now to address something that was bothering me from the first time I saw this, which is these removable jaws, but the fact that they are in just such terrible shape and that the jaw ledges underneath them are just completely gone. This is another thing that I didn't notice when I bought it, but it was one of the first things I noticed once I took it home. So I've got this thing clamped down to the table, and you can really see the broken jaw ledge here in this shot. Now, normally that would have gone all the way across, and honestly, I'm pretty surprised that this part broke unless somebody really, really abused this thing, because you can imagine in order to break that jaw ledge off, you would have also had to damage the jaws, and these jaws look to be factory and are in pretty good shape. But anyway, we're going to repair that now. Now I got some 1/2 inch by 1/2 inch steel bar, and I'm going to be basically grinding it and grinding in the actual cast iron body of the vise so that these bars fit nice and flat and level. We're going to go onto the milling machine a little bit later and tidy them up, but I want a pretty good fit here so that I can silicon bronze braze these on as well. And in order to do that, I'm just using a combination of the angle grinder with a cutoff wheel and then my little Dremel with a little cutoff wheel as well, just to get everything kind of lined up and clamped. And then I'll drill some holes, and I will actually drill and tap into the cast iron so I have a mechanical fit. And then again, I will go and do some silicon bronze brazing so that I have a welded fit as well. Now I'm just drilling these over on the lathe, and no, I'm not drilling them on the lathe. That's not a lathe, that's a drill press. I'm drilling them over on the drill press, and then I'm going to go back over to the vise body, drill a couple of holes straight through them into the cast iron, and then I'm going to just chase them out with the tap. Now I'm using an 832 tap on this, which is pretty small, but I'm not looking for a ton of strength on here. I'm really just looking for something that's going to act as a positioner that's going to keep from breaking off and just give me a little bit more of sort of a pinned fit so that when I do the silicon bronze brazing, it's a little bit stronger. Now this material can be a little tricky to tap. You have to be careful when you're blind tapping into cast iron, because if you hit a hard spot, it's very easy to break a tap. But you can see I was able to get those on with some countersinked holes and screws, and I just had to cut down the length of a few of them so that they would actually fit. And then I could get everything nice and tight. And you can see the way it's acting as a jaw ledge already. I'll cut it down to fit using the bandsaw, and then I'll start the actual brazing process. Now you may notice that I switched from the rosebud to a little bit more of a welding and brazing tip. I didn't want to get this too hot because I was worried about potential cracking. But what I realized here was I think the actual silicon bronze rod I was using was just a little bit too small. I was having some trouble getting it to flow properly. I also realized that I did not clean this part as well as I cleaned some of the other parts, and I think I was pulling up a lot of impurities. That being said, I did get a pretty decent silicon bronze weld, and because there was such a large area for that actual welding rod to settle into, I think it actually gave me a really nice bond. Now, similar to before, I let it sit in some sand overnight to cool down, and then I started working on the other one. Now, the other jaw actually had no jaw ledge at all, so I basically just ground in a little flat spot, and then I used a continuous piece of 1/2 by 1/2. Did the same thing with the 3 holes that I drilled and then tapped into the body, and you can see the original jaw sitting on there for reference. And then once I get everything bolted down, I cut it down to length, and I go through the same process of brazing it. You can see again, I have a V'd out area on the bottom, but I didn't really leave one on the top. So I ground one in using the angle grinder, and then I preheated everything, got it nice and hot, and was able to get that silicon bronze to flow in there relatively well. It was a very tricky process. This cast iron was really hard to heat correctly, and I just had a hard time in general. This was a really great learning experience for me on the silicon bronze welding, especially on something like this. Like I said in the beginning of the video, I've done it before a few times, but this was definitely the most I've ever had to do on one project, and it was very challenging, but I'm happy with how it came out. Now, while that was cooling down, I grabbed the meatball and the screw that I had just put back together, and I went over to the lathe to make sure that there wasn't any silicon bronze sticking out from where it was welded before, once everything was cool, so that it would have a nice fit and wouldn't bind or anything when I actually screwed it back into the vise body itself. Now, this isn't the last you'll see of this meatball, because even after I drill these holes for the cross pin, I'm actually going to have to increase the diameter of it later on in the video, because I realized I actually made it too small and it was not working great and not working smooth in the vise itself. Now I'm over on the milling machine just drilling in for a cross pin, just because I want to make sure that there is a ton of strength, because you can imagine how much leverage I could actually put on this if I tighten the vise down hard. So I drilled a 1/4 inch hole over in sort of the neck of it, and now I'm just drilling the 7/8 hole for the actual vise handle, which is going to be used to tighten it and loosen the vise. Now I'm just stepping up through the bits here and then eventually getting to a 7/8 reamer, and you can see the way this 7/8 piece of stainless steel bar fits really nicely in that hole. Now you'll see me actually put that 1/4 inch cross pin in. I just measured it for length, and I actually did throw a couple of little dimples in it with the center punch so that it would fit nice and tight. Then I preheated the end of the meatball with just a little MAP gas torch, and I gave it a quick weld to make sure that that pin could never go anywhere. Now with enough force, you definitely could shear that pin, but I don't expect that to happen given how small this vise is. And once I let those welds cool down, I could bring them back over to the lathe and I could just clean them up. The other thing I had to do was drill and tap the ends of the handle itself. Now this is, like I said, this is some 7/8 stainless steel rod, and I'm going to be drilling and tapping them with a 1/2-13 tap in order for me to put a little, basically small piece of threaded rod in there, which can then thread into a threaded steel ball for the ends of the handle. I also turned off the little bit of weld that was over there from when I welded that pin in. You can see this thing's a little bit out of round, but by using a live center in the lathe, it actually squares it up really nicely. And while I have everything chucked up, I also grabbed a 1/4-20 tap and I tapped the end of the meatball. This is for a sort of speed handle screw, which you'll see later on in the video. Now you can see how nicely that rod and handle fits in there, and you can see I put a little bit of 1/2 inch 13 all thread in the end so that I could cut it off and then screw it right into the end of those little threaded balls that I get from McMaster. And now you've got a completed vise handle with a meatball. Now remember, when I got this vise, it just had a chunk of steel welded to that, so this is a massive improvement and it looks really, really nice. While I was doing that, I was allowing the different vise jaw components to cool down in the sand, and once they are, I actually take them over to the downdraft table and I start grinding off some of the excess silicon bronze from those welding operations. Now this is the dynamic jaw, this is the movable jaw, and this one had the partial jaw shelf, so I'm able to grind down most of it and try to blend it in with the original piece, and it actually comes out pretty good. Now I'm going to do a little bit of a test assembly of these components. Now you can see there I've got the screw box and the actual screw and nut all put together. You can see the way everything threads together really nicely. And the way that this vise works, when you tighten it down at the actual screw. It locks everything in place so that the whole vise can't rotate. And I'm going to use that to my advantage to do a little bit of milling on those jaw shelves that I just made. Now this would have been a very difficult part to hold, so I thought I would use the actual body of the vise itself and bring it over to the Bridgeport and get everything squared away, and then I could actually just do my milling operation without having to worry about this thing moving or needing a weird fixturing set up. Now you can see I put a brass pin, that's for the actual rotation lock of the vise, and now I'm just taking a 1/2 inch solid carbide end mill and just running across the different surfaces to get them down to the dimensions that I need, and also just clean everything up so everything is perfectly flat and parallel. Now in theory, if everything is square on the vise, everything should be square from the milling operation, and you can see those 2 pieces of 3/8 inch brass bar fit really nicely in there. Now I'll wind up taking the handle off again just to get it out of my way, and you can see those 2 pieces of 3/8 brass that I have, and I'm going to be using as sort of soft jaws that I'm going to drill and tap into the actual vise body itself, and I am not going to go ahead and do the rivet method again. Now the rivets aren't bad, but I want to be able to take these jaws off and potentially make different ones if I want to. So we're going to go with mechanical fasteners here. Now the 3/8 stock fits perfectly in its thickness, but I have to make sure that I put it in the correct orientation, and then I'll take it over to the Bridgeport and I'll start the operations of kind of milling everything flat and square, and then I'll be drilling and countersinking for some 5/16 hardware. Now again, I just want to make sure that everything's nice and flat and square, so I mate these 2 pieces together, and I do a couple of very simple milling operations with a 1/2 inch end mill. Then I'm going to switch over to this 1/4 inch faired end mill, and for those that don't know I talk a lot about the Fair braces, but they recently started making some solid carbide end mills, and they're super high quality. I really like them, and I use this 1/4 inch one to make a little jaw shelf, which if you've watched my other vise restorations, you know that I like to put a jaw shelf so that I can grab plate. And I'll show you that a little later in the video on how that works. With everything clamped in there, I just mark the jaws, static and dynamic. Dynamic being the one that moves in and out, static being the one that sits on the vise itself. And I use the transfer punch to punch through some holes so that I would know exactly where to drill for these brass jaws. Now this brass in particular was really sticky, but it wasn't so bad once I got a good sharp drill bit in there, and I was able to use a nice countersink to get a really good and clean fit with these 5/16 bolt heads. Now, the holes that were in the vise were actually pretty much the perfect size to accept a 5/16 tap, which worked out really good. They were just a little bit over a 1/4 inch, which was what I was looking for. And I was going to actually switch over to just using 2 pieces of hardware to hold these jaws, but I figured there were 3 pins in there at the beginning for a reason, so I might as well continue with that tactic. Now I'm just running the 5/16 tap right into those holes with some anchor lube, and then you can see screwing in these 3 screws. And you can still see these screw heads on the jaw shelves that I welded on. I'm going to be changing that a little bit later in the video and welding over those and grinding everything flush. But you can see the way the brass jaws look, at least in the onset, super clean and nice looking, and they're really going to help me use this vise instead of potentially damaging the thing that I'm grabbing. Now, like I said, I am going to weld these screw heads once I got the welder set back up again, and I just ground them in a little bit with the die grinder and a drill bit so that I could get them nice and flush. Once they were welded and ground off again, I could go ahead and just file all the burrs off and make them look nice and clean. Now, for a final finish on this vise, I'm going to actually be using a boiled linseed oil. And the reason is I want the kind of scars on this vise to be visible. I could go ahead and fix every little defect and Bondo them and try to make it look perfect, but that's not the story that this vise has. This vise has been around for 100 years, and I want to show that. Now, what you just saw there was the sloppy fit on the actual meatball end of the screw. Now, this was pretty disappointing because I made this custom. I could have made it any size I wanted, but for some reason, I wasn't really paying close enough attention when I turned it down, and I made it too small. But that's what a welder's for. So I preheated it, and then I just basically glommed a ton of MIG weld bead onto it, and it looks terrible. I believe you. I'm sure you're staring at your computer thinking, oh my God, this guy is the worst. But don't worry, give me a couple of minutes on the lathe and this thing will look perfect again. So I glommed all that material on there, and then I just went ahead with this round insert on my lathe, and I just basically returned it to a larger diameter. It's one of the beauties of metalworking, is that you can pretty much keep adding and subtracting material until you get the result that you want. I also now took the die grinder and just sort of cleaned up that opening, and look at that fit. It is beautiful. Perfectly smooth with no bearings, just a good fitment and a little bit of lubrication with some 3-in-1 oil, and this thing's working great. Now I can put the shaft collar on, which is going to lock that screw in place, and I can give this thing a little test assembly. Now the next component that I need to fix / remake is the actual swivel lock. So you can see there's like an Acme thread on there and this little toothed gear, and that's cool and all, but the actual Acme thread in the base is completely stripped, like totally gone. And I knew there was no way I was going to be able to fix that. So what I did was I found the next closest metric thread, and I went ahead and I tapped it with this large tap. I think it was an M23, so a 23mm thread, which is a little bit under an inch. Now once that was tapped, then I needed to go ahead and cut the threads on the mating screw down piece. Now I don't think my lathe was set up to actually cut these threads based on the threads per inch and the diameter. I went ahead and I just bought a die on Amazon, and this was actually like a super easy way to do it. If you ever need to kind of quote unquote power tap on the lathe, or I guess power cut threads, you can just grab a socket that will hold a hex tap and grab a handle, and you can go ahead and just kind of cut the threads manually like that. I realized that the diameter that I was using was a little too large because the threads had a flat end on the end of them, but once I got to the correct diameter, I was able to actually cut pretty nice threads using a really quick method by just using that die in basically a giant socket. Now with that done, I could go ahead and kind of work on the rest of this piece, drilling and tapping the end similar to the way that it was before, and just making sure that everything fits and runs really nice and smoothly. I wanted to make sure that this thing would work correctly, and I didn't realize that I was going to need actually a little bit more threads. Now the thing that's interesting about this is those little teeth and the way that they interact with the actual bottom of the swivel base. Now, when I got this, those teeth were all really dull and kind of ground down. I went ahead and kind of sharpened them all, which worked really well. But I need to be very specific about the way that I make this, because this only really works kind of one way. The idea with the Acme screw, and I didn't realize this until later, is that Acme screw is supposed to be short enough that you basically give this thing about a half a turn in order to lock it down. Now, I'm going through all these operations thinking that I'm going to be able to put a pin through this that's going to be able to be turned kind of the way you would normally lock down a vise. You know, turn, kind of move the handle, turn again. So I'm counterboring and countersinking and grinding this screw down so that it's going to fit just perfectly, not realizing that it's never going to be able to turn all the way around. And you're going to see that in a second. Now, because the screw can't turn all the way around, no matter what I do, I realized that I actually have to weld the ends on this in place. So I had a little bit of tube and I just sort of put it on the end and knocked it in with a hammer. And then I'm going to go ahead and just sort of weld the outside of that. And that's going to allow me to kind of at least make it look a little more professional and clean instead of having this, you know, kind of janky stick there. Now you can see the reason that I can't rotate it because of the way the casting is on the actual vise body. You just can't get more than a quarter turn. So this was pretty critical that I get this tuned exactly right so that in a quarter turn it will lock down the vise and keep it from rotating. I'm very happy to report that I was able to get that using some washers and sort of just fine tuning things. Now you can see me starting to put the vise back together, and this thing is so heavy. That top piece that I'm moving around weighs about 150 pounds and the base weighs about another 100. So you're looking at a 250 pound vise, and it's very wobbly, so I'm constantly having to clamp it down to the table to make sure I don't drop it. Now I'm putting that lock screw in and just sort of moving things around to see how things are working, and it's all looking really good. Now it's time to make the triangular jaws that'll fit on the pin jaws of this vise. Now this is one of the very unique features of this vise, is having those pin jaws that can grab tapered objects or really kind of do a bunch of different things. Now you can see the design of the brass one that's over on my bench right now, and that's from my other Emmert vise. So I basically extrapolated on that and I scaled it up to fit on the 2-inch pins that I have on this one. Now I tried with a 2-inch hole saw, but it was too big, so I got another one and immediately broke it, which was great. That's what happens when you buy a cheap hole saw from Amazon. But I thought the carbide teeth on this would be helpful, so I cut off a little bit of the end and I was able to get it into a collet and was able to continue to drill holes. Now this is the 1.5 inch thick aluminum, and it is very gummy and can be a little difficult to drill. And of course, while I was drilling, I destroyed the hole saw that I had. I broke all the carbide teeth off and then basically had to go the old school way. I just took a drill now and I just drilled a bunch of holes around this because I was almost through. I was probably about 3/4 of the way through, drilling from both sides, and I thought, I'm not going to give up on this. I want to be done with this because I really want these jaws to be finished and ready to use because I need them on a project. So I just took a drill and fought my way through it, and then eventually smashed out that slug with a piece of steel and a sledgehammer. With all the machinery I have, it's really crazy that this is how I had to get these stupid holes inside this aluminum. I really got to learn how to use that ProtoTrack CNC that I got because I definitely could have done this faster on that machine. Now I just took a die grinder and sort of fine-tuned these holes a little bit. The pins are not round at all on this vise, so I needed to go ahead and just kind of make everything fit nice, which wasn't that hard actually. Just took a little bit of elbow grease and some time. Now I can actually go ahead and cut the 45-degree angle, which is going to break these into 2 pieces, which is going to allow me to actually use the pin jaws by having 2 of these. Now this is quick work for the bandsaw, just making that diagonal cut and then going ahead and make a vertical cut. And then I'll go ahead and put my template back on there and mark out exactly the way these are supposed to look. You can see the way they fit on the vise. They look a little goofy with those sharp edges, but it'll be quick work on the grinder to get them all cleaned up. I'll cut the little ends off on the bandsaw, and then I will cut the other end off near the rounded section as well. These things were actually really difficult to cut on the bandsaw just because they're so thick, so you have to kind of tip and rock them as you go, which allows them to cut a lot easier. Now I'll just grind and clean everything up on the belt grinder. In the end, I ground down all the surfaces, made everything nice and flat, added a little chamfer, and they turned out really nice. Now I wanted to mark these with a static and dynamic S and D because they are a little bit specific to the pins that are on this vise, and it was pretty easy just to do that, and it'll just allow me to make sure I grab the right ones. Now the last component to make is the actual rotation lock pin, and you could tell there it was just made out of an old bolt previously, so I'm going to make it out of some brass over on the lathe. I throw in a piece of 3/4 inch bar stock and I drill a hole in the end so I can get my live center in there, and then I turn it down to the diameter that I need. Now I wanted to make this out of brass just because it's a nice little accent piece and I think it's going to look good in the end. So once I got everything turned down, I just smooth everything out with a file. Be careful if you ever do this, especially be careful if you're using any sandpaper. But I wanted to have a nice smooth finish. Then I went ahead and used a knurling tool to add a little bit of texture to that screw. And then I can go ahead and use a cutoff tool to just break this off. It's a very small part. It seems insignificant, but it makes a big difference in the actual functionality of this tool to actually have the locking pin. I used the cutoff tool to cut that little end off, and the reason I left this little end on there was so that you could flip the pin over and stick it in that hole so it wouldn't really have anywhere to go. Now I just needed to go over to the belt grinder and grind a little taper on the end so that it could fit nicely in the hole and definitely lock in to the actual body of the vise. Last thing I did was take a 3/8 drill bit and just clear out some of the gunk and kind of make sure that those holes were nice and round for this pin, and you can see how nicely it works to lock in the vise. The last thing I'm going to do is add this little spring detent ball to the end of the meatball, which will go into a little slice that I put in the handle, which will lock everything in place. Now I'm cleaning everything up with some degreaser, and like I said, I'm going to be using some boiled linseed oil as a final finish on this because I want to preserve its history and show that it's been repaired and show that it's got some scars. Now I can show you the way this vise actually functions. It can be lifted up into these different positions. It can be rotated. You can see the way the pin jaws work, and overall this thing is absolutely amazing. 250 pounds, a giant vise that needs a proper stand. So leave a comment down below if you can give me some suggestions on what the stand would look like. I hope you enjoyed this video, and I will see you on the next one.